So, so numerical methods or numerical analysis is a branch of mathematics. Analysis is a branch of mathematics. Branch of mathematics for solving, used for solving equations such as normal equations, ODE, integrations, etc. So these techniques, for example, if you take some ODE like y dash square plus y cube is equal to some sine of x cube. So this is a first order nonlinear ODE, but such equation we cannot solve by direct method. That means there is no direct method to solve such equations. Okay, that means we cannot find y of x, unknown function y of x, by any uh, method. So in this case, what we will do is we will use some numerical techniques and find approximated solution y of x for this differential equation or any other kind of equations. So some equations are difficult to solve, then we will find an approximated solution. So by numerical techniques, we will get an approximated solution. So there might be error. And these techniques, we will use iterative method. That means we will find one solution, then we will perform again the process. X1 is one solution, then we will perform again the process, then we will get more accurate solution x2, then x3, etc. So this is an iterative method, and finally we will get the most accurate solution. That means most accurate or less error solution. Now I will define what is error. So if a tilde is an approximated value of a quantity whose exact value is a, then error is denoted by epsilon is equal to, or e is equal to, error e is equal to a minus a tilde. That means a is equal to a tilde plus error. That is, true value is equal to approximation plus error. But in some cases, we will use a relative error for measuring error. So, relative error is simply denoted by ER, which is equal to error divided by actual value or true value, a minus a tilde divided by a. Or we will use absolute values. That is, error by true value is relative error. So while using numerical techniques, we will get a approximated solution a tilde, and if a is actual value, then there may be some error a minus a tilde, or we can use absolute value also. So this is the definition for error. So first we will okay. First we will study to solve root solution of some equation. Okay, by iterative method, solution of equation by iteration. Equation by iteration. Okay. So first of all, I define an equation. Consider an equation f of x equal to 0, then where f is a function. For example, if f of x equal to some e raised to x plus sin x, so this is a function, and if I substitute it is 0, you will get an equation. Okay. Then a number s such that f of s equal to 0 is called a solution of that equation. Okay? What is a solution? A solution of equation is the number s that f of x equal to 0. For example, f of x equal to x square minus 1. Then here f of 1 is equal to 0, f of minus 1 is equal to 0. Therefore, 1 minus 1 are solution. Right. So, for a polynomial of degree 2, degree 3, even degree 4, we can find a solution by using some formulas. But for degree 5, there is no method to solve polynomial of degree more than 4. Okay. So in this case, or for any other equation involving sine, cos, or exponential logarithmic, then it's very difficult to find solution. So in this case, we will use some numerical techniques. So the first technique is very important technique, Newton-Raphson method. Newton-Raphson method. So this method is used to find the solution of x equal to 0. That means what you mean by solution? So suppose this is a function f of x, y equal to f of x. Then the point, this point, this is some s. Here f of s equal to 0. So the point at which f intersect x-axis is called a solution. So here S is the solution. Right. So what is Newton-Raphson method? So I will give an idea. First, Newton-Raphson method. It is an iterative method. Iterative method means we will first find one solution, then do same process, and you will get more approximated solution, more accurate solution, and we will continue the process. It is an iterative method for solving equation. The Newton-Raphson method is an iterative method for solving equation of the form f of x equal to 0. And the condition is, so we can use Newton-Raphson method if f of x has continuous derivative f dash. So f of x must have continuous derivative f dash. Now I define what is that process. So what is the Newton-Raphson method? So suppose this is x-axis, y-axis, and so this is, suppose this is y equal to f of. Suppose this is y equal to f of x function. Now I want to find this. That means this is the solution. S f of s equal to 0, and we don't know what is s. So we want an approximated value for s. So for that, what we will do is we will first find an initial solution x naught. So we will suppose x naught is a point nearer to s, and then we will assume that is we will take any value nearer to s. So, so our first iterated value is x naught. First value. So next, what we will do is, so this is f of x naught. This length, right? This length is f of x naught. Now what I will do is, since f of x is as derivative, we will find the tangent line at this point. So this is the tangent line. And I call this is the second iteration. So next what I will take is the value where the tangent line touches x-axis. That is my second iterative value. So what is that value? If this angle is beta, then we know that slope of curve is equal to tan beta, and we know that this tan beta is this length opposite by adjacent. So that is f of x naught divided by this length is x naught minus x1. And we know that slope of the curve is f dash of x naught. This is f of x naught divided by x naught minus x1. So which implies x naught minus x1 f dash of x naught is equal to f of x naught. This implies x naught minus x1 is equal to f of x naught divided by f dash of x naught. Which implies, so what is x1? We get value of x1 is x naught minus f of x naught divided by f dash of x naught. So we will get the second iterated value x1 from this formula. So x1 is x naught minus f of x naught divided by f dash. Now I can find what is f of x1. Now what I will do is, again I am taking the tangent line, and that tangent line touches here x2. So this x naught is far away from s, but x1 is nearer to s, x2 is somewhat nearer to s. Okay. So similar process, we will get x2 is equal to same x1 minus f of x1 divided by f dash of x1. Similarly, what we will find, again this is f of x2. Again I am taking the tangent line x3. Then x3 is much nearer to s. So what in general, what is Newton-Raphson formula? Xn is equal to, xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So this is the formula for. So what we will get, x naught, that is initial value, x1 you can find, x2, etc., xn, etc. So while iterating, if you get a 4 digits, 4 decimal points equal, then we can stop. So now we will do a problem. Anybody have any doubt? This is the formula for Newton-Raphson method. What is formula? If you have given f of x and f of x is differentiable, then Newton-Raphson formula is xn plus 1 equal to xn minus f of xn divided by f dash of x. So now we will do a problem. Apply, apply Newton's method, Newton's method or Newton-Raphson method to find a root of f of x equal to x cube plus x minus 1. So here there are 3 roots because degree is 3. So we can find any of the roots. The solution, first you write down what is f of x. F of x is given x cube plus x minus 1. So this is a polynomial, therefore I can find f dash of x. Yes. Now I want to find x naught. അപ്പം നമുക്ക് എക്സ് സംടൈംസ് they will give in the questionൽ x naught തരും, otherwise they will not give x naught. So I want a x naught initial value which is nearer to s. So how to do that? This is our y equal to f of x. Now if I find a value here, this is a negative value, some f of, suppose s1, s1 less than 0, and if I am taking this value s2, f of s2 is greater than 0. If s1 less than 0 and s2 greater than 0, then in somewhere in the middle there is the our required root. So if some value is greater than 0 and some value, for some value if is less than 0, somewhere middle there is a root. So far, so we will find that. So take f of 0 here minus 1, this is less than 0, and if I am taking f of 1, 1 cube plus 1, 1, this is greater than 0. Okay. You can take it. Okay. Now thus what you can say, we have f of 1 is greater than 0 and f of 0 is less than 0. So somewhere in the middle there is a, thus there is a solution for the polynomial in between 0 and 1. So now we can take x naught is equal to anything in between 0 and 1. ഏത് വാല്യൂ എടുക്കാം. Okay, that's our choice. Anything in between 0 and 1. So I am taking just 0.5. So anybody have any doubt? So how to take x naught? Sometimes in the question itself x naught will give. Otherwise, what you have to choose, you have to find the check. So for some values this is less than 0 and for some values it is greater than 0. Then some value middle you can take x. So here in between 0 and 1 there is the root and I am taking x naught as 0.5. So now you write down the formula of x and 2. So xn plus 1, Newton-Raphson formula, xn minus f of xn divided by f dash of xn. And we know that f of x is x cube plus x minus 1, f dash of x is 3x square plus 1. Now I am writing x1. So for doing this, you must have a scientific calculator. Okay, you must buy a scientific calculator. So this is x naught xn plus 1 when n equal to 0 minus f of x naught divided by f dash of x naught. So this is equal to x naught is 0.5 minus f of x naught 0.5 all cube plus 0.5 minus 1 divided by f dash of 3 into 0.5 all square plus 1. 3 into 0.5 all square plus. So by using calculator calculate you will get this value is 0.711428. So the first iterated value is 0.711428. So we get x1 is equal to this. Now you find out x2. x2 by formula x1 minus f of x1 divided by f dash of x1. So x1 we know 0.71428 minus f of x1 428 all cube plus 0.71428 minus 1 divided by 3 into plus 1. So by using calculator, you will get the value as 0.68317. And similarly, you find out x3. x2 minus f of x2 divided by f dash of x2. x2 is 0.68317 minus of 0.68317 all cube plus 0.68317 minus 1 divided by 3 into 0.68317 all square plus 1. Now we will use calculator. Calculator you see the in and the term 0.682715. So this is 0.6831719 and our iteration becoming similar 0.682715. So here and up to 2 decimal place it's same. If we get up to 4 decimal place or 3 decimal place, we can stop. Up to 4 decimal place you can stop. So I am finding x4, x cube minus f of x3 divided by f dash of x3, which is equal to 0.6821715 minus 0.6821715 all cube plus 0.6821715 minus 1 divided by 3 into 0.06821715 all square plus 1. And if you calculate by using calculator, x4 is equal to 0.682715. So x3 is also 0.682715, and sorry, x4 is 0.6825. So here up to 3 decimal place it's same. So we can stop here, or otherwise you can find x5 and stop, or x6 and stop. So up to 3 decimal place we can stop. So the solution is 0.6825 approximately. Approximately. Now, now we will do one more problem. Okay, I will give you a homework. Okay, so find a real root of x log to the base 10x equal to 1.2, correct up to 5 decimal place. 5 decimal place. That means correct up to 5 decimal place means last solution it is correct up to 3 decimal place. നേരത്തെ 3 decimal place ആയിരുന്നു. And for this question we have to find solution correct up to 5 decimal place. Okay. So from, and also one thing, this is base 10. From the calculator you will get the value. So here f of x is equal to x log x log to the base 10x minus 1.2. Okay. Then f dash of x is equal to derivative of this x into, or derivative of x is 1 into log 10x plus x into derivative of log 10x. Into d by dx of log 10 to the base. Okay, then you find out this, do this, and I will give you hint. You have to find out x naught, so you can choose f of 1 and f of 3. Check values for f of 1, f of 2 and f of 3. Then where somewhere between 2 and 3 you can find the value, and you can choose any value between 2 and 3, and you can perform the iteration. So the answer is 2.740, 2.74065, correct up to 5 decimal places. Okay. Please do this problem. Okay. So this is your homework. I will send you that question in your WhatsApp. Anybody have any doubt? I will send that question in your WhatsApp group. So by using Newton-Raphson method, we find C4. Okay. So I have sent that question in your WhatsApp group. Please try to do that. Thank you.
Thank you, sir.
I say log x